Everybody, hi. Welcome to South Bay Selenium Meetup. Thank you for showing tonight. I'm Amit Desai. I've tried to shake hands with some of you. If not, sorry. We'll be having a speech from Manoj Pahuja, who is the speaker from GoDaddy. Before that, any announcements to make?
Hi everyone. My name is Igor and I represent Bay QA Training Group. We are conducting 8 weeks bootcamp focusing on test automation for web clients, and in parallel we're going to run 5 weeks bootcamp for the iOS client. If you're interested, please stop by after the meetup. See me, I'm here, front row, and I can share with my business card, and if you have questions, feel free to ask. Thank you.
Thank you. Any other announcements?
I have an announcement.
Okay.
Yeah, I can probably talk here. So we are hiring, so if any of you is looking for a job, please feel free to contact me offline via email or after the meetup, and we can discuss further.
Thank you, Manoj. Any other announcements? Going 1, 2, and 3. Okay. Okay. Before we begin, let me thank you to our sponsors, Sauce Labs, who is sponsoring us, and thank you to GoDaddy, who is sponsoring or hosting the second meetup over here for Selenium. And a big applause to Manoj Pahuja.
Thank you, Amit. I'll just use this mic. Hello, everyone, and good evening to all of you. I hope you're still awake, not after the food that you ate. So we're going to talk about some of the things around continuous delivery, automation, alerting, reporting, a lot of those things. And we're going to show some magic. So before we show any kind of magic, raise of hands, I just want to kind of pace my presentation accordingly. How many of you would consider yourself kind of slightly advanced or intermediate users with using Selenium? Like, you know some quirks of it, you have used it for the last few years, and you're just looking to advance your skills in automation or in Selenium general. Okay, cool. And how many of you would consider yourself to be kind of beginners? You have heard about Selenium, you want to know more, how does it work, and what are some of the things that you can learn, and you're here to know what Selenium can do for you. Okay, cool. So I think we have a whole bunch of people in that category. So being said that, how many are you, so overall the agenda for today, the things that we're going to talk about, the terms and technologies, since there are a lot of people who are still getting familiar with Selenium, what are some of the good characteristics that would define that the test that you wrote is a good test or is a good automated test? And then what are the matrices that you can use to define and measure the goodness of that test? And then, some of the things that you can do to actually, after the reporting, to debug those tests, improve those tests, improve the reliability, improve the speed of those automated tests from a UI perspective. And then the different kind of alerting that you can implement or have in place, possibly. And we can talk about what are some of the things that we have done here at GoDaddy, and then some of the things that we haven't done, and then you can implement at your company depending upon your needs. So going back to my second question that I wanted to ask is, how many of you are familiar with this concept of CI/CD, continuous integration? Can one of you maybe define in simple words what it could possibly be? Do you have the mic? Anyone? Any volunteers? Okay.
So, from my perspective, what continuous integration and continuous delivery means from the point you check in up to the point you deploy to the server. This whole process is called continuous integration and continuous delivery.
Okay, that's good enough. Any caveats to it, or any kind of terms and conditions that you would usually apply to that process? So you want to be able to continuously do that in an automated fashion, right? That you check in something and then it automatically gets deployed to production. Anything else that you would usually associate with that?
So I can try to break the process in tiny segments. So everything starts from the code check-in from the developer.
Perfect.
And then that code builds up. Sometimes it's pull request, merge a job, or anything else.
Awesome.
It builds. Once you build the binary, if it's a web application, you obviously need to deploy somewhere on the
Sure.
test server. Then you need to test that. So you
Uh-huh.
run some sort of smoke end-to-end acceptance test. If that check is green, then green light, you deploy it. And then it can deploy to production server, pre-production server. If it is true continuous delivery, it will go to the end user. If it's native app, it could be deployed to Hockey app, or it could be deployed to Crashlytics and then distributed as a dog food to the end user. So that's
Awesome.
like true.
Yeah, perfect answer, perfect answer. Round of applause. Thank you so much. I think in simple layman language, I would define it a way or a process which is completely automated, which allows you to deploy a piece of code to production with good test coverage and enough testing. So the things that he just defined from a process perspective, you first do a commit through a PR or any kind of other mechanism, then you do build, and then you run all your tests, whether unit tests, integration tests, UI tests, performance tests, any kind of test, and then it finally gets deployed to production. So today we're going to focus mostly on that, layer of testing from a UI perspective. And you can apply some of these technologies and things to integration tests as well. So, talking about terms and technology. So, we use RSpec, which is a test runner with Ruby as the primary language for our purposes. And then there's this concept of rake file, which is the counterpart of a POM file in Java Word, or a grunt file in a JavaScript world, where you can create specific tasks based on conditions, and then when you run that particular file or that particular job, it gets executed through Jenkins or any kind of other CI tools that you may be using. The last thing is the ELK stack. We're going to go into a little bit of detail what exactly is that. So the first component of that ELK, where L stands for log stash, it's basically a log event or log file collector. This is an open source tool that you can install on a server, and you'll be able to send your log or any kind of events or log events to that. And then on top of it, where E stands for Elasticsearch, it allows you to make queries through an API on the logs that you have just created. So calling these APIs, you can search for any specific kinds of logs and then query on them and find the data that you really need. And Kibana allows you to create some kind of graphical representation of that data, where it wraps all the APIs that have been exposed in Elasticsearch and gives you capabilities to draw graphs, pie charts, bar graphs, and things like that. So we use that stack for our purposes. We're going to go into details of how and where we use it. So again, one more question. Hopefully this will be the last one. What, according to all of you are good characteristics of a good automated test? No? You can talk from there, I think.
I think is to think back at what you're trying to accomplish with the automation, and what you want is to have a good regression that's going to cover your code base and the tests that are most likely to break from regression moving forward. So, you want to accomplish several things. You want to allow you to save money by not having to do it manually, do the testing manually all the time. And you also want to have the coverage to cover the important test cases that are going to break on your customers so that you don't lose business from breaking the
So are you saying, if I understand it correctly, you're saying a good automated test would be a regression test that would help you save time and also give you enough coverage for the product, and it's probably one of the fragile areas of the app, and hence you're able to find bugs with that test? Okay, okay, okay. Anyone else? All right.
I think I'll try to speak out loud. The major characteristic of a good automated test is number one, stability. It has to be stable. Thank you.
Okay.
The automated tests, they have to be stable, otherwise there is no purpose. They have to be relatively fast in a continuous delivery. It's also important.
Sure.
And probably that's the two most important characteristics. And they have to find defects, obviously, right?
Okay.
They have to be meaningful. You can write a test that always pass. I mean, that's good. And then it has to be good return on investment.
So I think that kind of ties back to what he was saying. It gives you good coverage, and it also kind of covers the business value and the business cases.
So one of the main characteristics of good test automation is maintainability. So when you have one script, you can like hello world, you can do anything, store it wherever you'd like.
Sure.
But if you have 1,000 scripts, you need to have a framework. And the framework should be easy maintainable. And the most important characteristic of the good test automation framework is data-driven approach.
Okay.
Because without data-driven, so any API, the primary technique for testing any API is data-driven. So it's impossible manually to, or even using, by programming to enter some hard-coded data.
Right.
And so it requires a lot of different combinations. So I just wanted, there are of course other frameworks like a keyword-driven testing, but I don't like it. So,
Right.
And yeah, okay, I will provide more comments along the way.
Okay. Anyone else?
Yes, I would add a few more comments for that. Yeah, for design the automation task, you design as like a modular. So if you happen to not to have one module ready, you still be able to run the other module in your automation task. The key thing is, yeah, you want to make it low maintenance, because if you don't do that, you kill yourself and you defeat all the purpose of automation.
Uh-huh. Yeah, makes sense. I think it kind of ties back to what he was saying from a maintainability aspect. You're saying from a design perspective, it should be modular enough that it's easily maintainable. I think it's kind of a design implication of me being more maintainable. I think all of those points, I have them covered here in slightly different format, I think. The stability aspect, I just worded it differently. It needs to be highly reliable. That it needs to be stable so that when you run it, you know that if it fails, there is a reason either it's an environmental issue or it's an actual bug. Should be, that's one thing that I added besides a few things that all of you talked about, that it should be able to provide fast feedback from a developer perspective, so that you don't have to wait for a very long time to understand and know that if you broke anything existing that was there from the code changes that you just made. Faster execution time is definitely a key, because if your tests are going to take 5 hours to execute, the essence and the value of it slowly starts to deteriorate. The last thing that I also want to add that ties back to the maintainability aspect is that if a test fails, you have some kind of mechanism to be able to quickly get better report or better exception, or it's written or designed in such a way that you're able to debug it much more easily, because it provides you the reporting built into the framework or built into the test. So keeping those things in mind, what are some of the matrices that we can actually use to measure some of those things is what is going to be the main crux of this presentation. So for execution time, one way of improving the execution time is to have the test written in such a way that it's fast enough. But once you have thousands of tests, as this gentleman over here pointed out, you want to be able to run those tests in parallel. So you can obviously run multiple tests in parallel on one box, and then you can add multiple boxes that are running multiple tests in parallel, and a simplified version of how you can actually scale up these tests. And technical implementation of these could vary from different companies based on the support and the ops support, and so you can have a grid implementation, or you can have a remote web driver implementation, or you could actually be running on physical boxes these tests where you have threading implemented within your framework to be able to execute those. For us, we use the remote web driver instance. We have multiple VMs which we have spinned off to be able to run those tests in parallel. Right now we are not using a grid configuration, but eventually we want to be able to use that. The second thing that I want to kind of explain from a faster feedback perspective that we talked about for the good characteristic. Here I'm just taking an example of the product that I work on, which is called Website Builder, for short, WSB. So tying back again to the CI/CD aspect, once a build gets deployed to test, we run a smoke job, which again is run in parallel, which runs a bunch of tests, making sure that the basic functionality or the smoke functionality of the product works. And then once that passes, then it triggers a whole bunch of tests for us, which again run in parallel, the scaling that we talked about earlier. So we have this concept of, let's say, 4 buckets, which are a regression suite, which we divided into 4 equal or unequal test cases. And those tests run in parallel, and we always expect these tests to be passing. If any of those fail, then it means that there is a bug in the actual application, or the environment was having some kind of issues. And then I want to kind of introduce this concept of TUT, which we call as tests under test. So any new test that gets written for our UI automation purposes goes into this bucket. So we kind of let it bake there, we run it multiple times. If the reliability of this test is high enough, and you can set different benchmarks. For us, it's 90%. So if the test works 90% of the time, so our last 7 days, then it gets moved into one of these regression buckets, or it gets moved to a nightly bucket, which is, these tests are important, but they are not important enough to be run against every single build that gets deployed to our test server. And this nightly test job is also run at night against the latest build of each branch that happens during the day. So from a scalability perspective, that's how we kind of distribute our tests and run them in parallel. And then we also make an effort from our side to go back and review these tests and see if the tests are still relevant and important for us. Then we keep them, otherwise we update them or delete them. So as an example, if you're working on a new feature, you write, let's say 10 test cases. At that point, all of them seemed important because it's a new feature and you want to be able to find more and more bugs and you want it to have more coverage at the UI level. But then later on, as there are no more changes that are happening for that particular feature or that piece of code, and you have a lot of unit tests and integration tests, you might want to go back to your UI tests and get rid of them. And that definitely helps with improving the maintainability of your tests. Because they need to be relevant as well. Question?
Yeah.
I have a question about which tests go into the tests under test. You said some tests are unreliable. What do you mean by that? Why did the tests under test fail?
That's a very good question, and I'm sorry for not clarifying that. So some of the tests could be unreliable for primarily 3 reasons. That's kind of our general observation from working on automation. First, it's badly written code, and hence, the test fails. That you're not waiting enough, or you have some kind of sleeps, or you're not waiting for the right kind of elements and things like that. And the test is badly written, and hence it becomes unreliable. The second would be the environment where the test is actually being run is unstable. Like, let's say, for example, an API randomly fails, and which makes the test at a UI level unreliable. So let's say you're in the UI, you're expecting a certain event to happen, but in the background you're making an API call, and it randomly fails, then the test will become unreliable. And this is just one example. There could be several other examples which, in general terms, are environmental issues that cause a test to be unreliable. The third thing is a test would be unreliable if it's an actual bug. So if it's an actual bug in the application, then it's going to fail. And the business may decide not to fix it because it's not urgent or important. So then you have to go back and reevaluate whether you're automating the right test cases or not. But primarily, those 3 reasons a test could be failing. New tests, that's why I go there, because you want to be able to diagnose and analyze and run them enough number of times so that you rule out the first option, saying the test is badly written. Does that make sense? Okay. Moving on. So with this, I think the problem comes in. Let's say I'm a developer, I check in a code, I get a build deployed, and all of these jobs get run, and let's say a whole bunch of tests fail. So as a developer, it would be more painful for me to look at all of these different kinds of links and figure out which test failed and why it failed. And that's where our ELK stack comes into picture, where we create this kind of dashboard. Don't worry about if you cannot read anything. I'm gonna go into each individual panel, and I'm gonna show you a demo as well. But each of these jobs get reported into this dashboard. So with the Logstash API, we send every single event that happens within our tests, whether it is methods being executed, whether it is the actual job finish time, execution time, or whether it is the actual test result that gets executed within each job. We send that information to this dashboard. And then as a developer, you can go to this dashboard, filter out with your build. The build is on the top here. You just click on this bar, and then it gives you the result for your particular build. So you can even get performance matrices, you can get UI test results matrices, and your actual environmental issues as well on the dashboard. And we're gonna see how. So what are the useful matrices that are gonna help us improve the overall value of our automation. So in general, I've tried to summarize and put them as 3 main items. We want to be able to measure their execution time, we want to be able to measure their reliability, and they should provide clear and precise and appropriate kind of results or report associated with that. And the actual technical ways of how you can measure these three things is what I'm going to show you. So on that dashboard, the first thing we measure is how much time does each of those jobs that gets executed takes. So that would give me my fast feedback information. So when I commit my code, in how much time would I get the results back for the check-in that I just made. So as an example, for our case, it takes on an average 23 minutes to run all our tests because all of them are executed in parallel. So after a build gets deployed to 23 minutes, the developers get notification, hey, here are the test results for your build that just got deployed to test. Then we obviously measure the execution times for each individual test over a period of time. Here I'm just showing the execution times for failing tests, but we measure the passing tests as well because we want to be able to categorize our tests into 4 main buckets to kind of help us make more informed decisions. The first one is fast reliable, slow reliable, slow unreliable, and slow reliable. So that way we are able to refactor some of the tests and go back and review them, and then if our tests are slow and unreliable, then we need to either refactor it or get rid of it. Or if our tests are slow and reliable and the slowness is enough for our tolerance, then we can still leave them. But we should always strive for having most tests to be in those 3. The slow unreliable bucket is the one where we should have the least amount and the least number of tests. So that categorization kind of helps us define and manage our tests a little bit more appropriately. And I'm going to talk about where we use that metric to utilize and manage our tests towards the end. We also kind of profile our individual methods. So kind of these are the helper methods that we have created, which helps us with maintainability and code reusability for across all our different tests. But we want to also be able to make sure that the methods that we create are not like very long, so that if one breakage point happens, then it breaks a whole bunch of tests. And we want to be able to keep our individual methods small from a code perspective and also small from an execution perspective. Yes, question?
Do you really need such accuracy as putting digits after the dot?
So this is just something that came for free from Kibana. We're not really doing anything. We just send a round number and then it gives a mean over a period of time. So this is something we don't send as the data from our perspective. I mean, if you do whatever, I don't know, 500 divided by 9, then you'll probably get something like that.
But I can truncate it, so it's,
Sure, yeah, I'm sure there is some kind of setting that would allow me to truncate and only show a point. But from an actual consumption perspective, whether it is 2 digits or 15 digits, I think it doesn't make much of a difference. So the next thing we want to be able to see, how do we measure the reliability of a test? So this is just an example. On the dashboard, I was able to create a filter and said, what is the reliability of this particular test in last 7 days? So it ran 32 times and it failed twice, and then it worked 30 times. So it gives me the reliability as 94%. So in our books, that's something we consider as a reliable test, because those 2 failures could possibly be environmental issues, or they could possibly be bugs, but the reliability of our tests is solid. But creating something like this for thousands of tests is going to be a lot more painful, and your dashboard is probably going to go insane and unmanageable. So we put it in a kind of a tabular format where it gives the count of the tests or the count of the times that test has failed. So here I'm just showing top 10 failing tests in last 8 hours. So the first test is obviously the most unreliable one because pretty much it failed every single time. So we know that there is some problem in that bug because of any of those 3 reasons we talked about. So on a daily basis, we get a notification and saying, this is our culprit for yesterday. We need to go back and look and fix it. So that's how we kind of consume this data on a day-to-day basis. Capturing exceptions, so anytime a test fails, we capture the exception and we send it here as well. This allows us to kind of draw a general pattern around why multiple tests may be failing at the same time. And this significantly helps us because you can add specific exception handling where you can say, if it is an environmental issue, raise this exception. So as an example here, where it says build issue control panel page failed to load, that's a custom exception handling that we added, which we send here. And we are able to quickly quantify and say, hey, our tests are failing because we are seeing these environmental issues. So then we work with the ops team, the dev team, and a whole bunch of people and then say, hey, this is why it's failing. Here is the error that's happening. And this is why it's happening. So we need to fix it. And here is the number of times this test has failed, or these tests have failed. So having this kind of data adds more weight to getting these tests fixed or getting our environment fixed as well. And for debugging purposes, it helps as well because you know that there are a whole bunch of timeout errors coming from one particular method. So you know that if you fix that method, it's going to fix a whole bunch of tests at the same time. So it saves and helps with maintainability of the tests again. Another thing that helps with improving the maintainability of our test is within the test report, we attach a screenshot along with the complete stack trace with the timestamp for the error that happens. So if a test fails, we take a screenshot, attach it to the report, and attach the stack trace and attach the timestamp. So a screenshot would look something like this. So that particular page behavior test failed, and the third within that spec file failed. Here's the entire stack trace. And then in the screenshot, you can see there was an actual error that happened in the application. So you can look at the logs. So from a developer perspective, you get easy access to the information that you need, and you avoid a lot of back and forth and trying to understand what are the repro steps. Because the entire script is here, the entire steps are here, the screenshot is here, you get the logs on the server as well. So this is a gem that we use called Allure. I'm not sure if a lot of you have used it, but I found it very useful to be generating for our failing test because it gives you these capabilities for free. So kind of summarizing from experience and improving and showing or having improved our reliability, what were some of the reasons that we found for our tests to be unstable? The first one is the timing issues, meaning badly written code for, let's say you're waiting for something and you're not waiting long enough because when you run a test, let's say remotely or in a VM, the timing for the wait is not enough. So let's say you say wait for an element for 10 seconds, but because you're running remotely and you're running on a slower machine, it takes more than 10 seconds as an example for that element to show up. Hence the test would fail. So that's kind of one of the reasons why our tests have been failing. The other one is obviously the environment performance issue. So you have enough wait times accounted for from a machine resource perspective or a test runner perspective, but the environment is not behaving appropriately at the time the tests were run, and hence the tests fail. So you click on a button, usually it would take 5 seconds, but now it takes 15 seconds because there was some problem on the test server, the CPU is high on the servers, and hence it's failing. Hard-coding accounts within the test, again, going back to having your tests designed appropriately where you don't have that, whether you use configurable values or you use some kind of data-driven adoption for you to be able to not running into situations where you have those and hence your tests fail. The other reason why these tests have been failing is because the boxes or the VMs where we run our tests, if let's say a test fails and for whatever reason the browser is not closed for that particular failure and you have a whole bunch of browser instances running on the VM or box, then it would quickly run out of resources and then it would cause subsequent tests to fail as well. Changes or configuration that were affecting the test environment as a whole. So we do a lot of kind of A/B testing for a lot of the functionality and features that we release. So if there is a configuration that was changed for the entire application because we are trying to do a B flag versus an A flag and the code is not updated for us to be able to handle, then our test would fail for those situations and those scenarios as well. So what did we do to actually improve the reliability of these tests? The first thing we did was being able to rerun only the failing tests. So when a job is run, we gather all the tests that failed in the initial run, and then we rerun only those at the same exact time. So this greatly helped improve our reliability because the timing issues or the performance issues with the test server were kind of overcome by just doing this. Yes, question?
You do it happen automatically or is rerun, or you rerun it manually?
It happens automatically. So we gather all the tests that failed and then we rerun those. I'm going to show you the actual technical implementation of how we have done it. So just hold on to that thought and I'll explain how we do it. Capture exceptions, the thing that we talked about, being able to capture the exceptions over multiple builds helped us improve the reliability because we could tell which particular error keeps happening. Like one common error would be stale element, where we expect an element to exist, but the app has moved to a different state and the application or the element doesn't exist anymore. That's just an example, but being able to have concrete data around the exceptions definitely helped improve our reliability and help us debug those tests. We also created an API which allowed us to do data-driven testing, where within the test we would just make a call to an API service and it would return the information that we need for our tests to be able to execute it in an independent way. And this also helped us avoid situations where, let's say, an account for whatever reason went into a bad state and it's completely unusable. We would be able to quickly delete that from the API's database and then not allow that account to be used in any of the tests. So that would greatly help us improve the reliability of the test as well, excuse me. Capturing screenshot, definitely very useful, very helpful to debug the test, quickly understand what happened, where was the error, what was the state, the application, and we can look at the logs and greatly, again, debug the test and improve the reliability. Alerting, so by no means these are the only ways of having alerts, but these are some of the mechanisms and things that we have implemented to get the information to the right people at the right time. The first is obviously when a developer creates a PR, everybody gets notified about it, including stats, QAs, everybody on the team. So they know what code has actually changed to be able to understand what test might break at that point. Email from Jenkins, I don't see this as a very good alert, but if your jobs are mostly green and you get a once in a while email from Jenkins, I think it becomes useful. But at one point, when all of your tests are failing and they're failing 100 times a day, then you lose the essence of getting an email from Jenkins. We still have that implemented. Some people look at it, most people don't. Slack. We use Slack for collaboration purposes. How many of you are familiar with Slack? Anyone? Okay, only a few. But it's basically, I'd just say in a stupid way, it's like Facebook of enterprise, let's put it this way. But it helps you collaborate with other people, exchange messages, exchange files, get notification. You can tag people and they get alerted, and things like that. So this is like a lot of people just spend their day working on Slack. So this notification definitely helps. When their name gets called out on an entire channel, which is open and public, it gets more accountability built into people who are working and consuming the automation. So this is definitely one of the useful alerts and notification we have. Email from Jenkins. So after you create the PR, other developers would usually look at your code and give review comments. But from an automation and CI/CD perspective, after the tests are run, we give a thumbs up and say, hey, this job passed, and these are all the tests that have passed for that, and that gets added into the comment for that PR. So if any of the tests fails, then it becomes the responsibility of the developer to look at and see why the test failed. And if it's actually a code change that broke that test and it's a bug, then they have to go fix it. So this has hugely saved a lot of times from a QE testing and SDET perspective, because without even touching the code, you're able to find regression bugs that get notified and alerted to the developer who just made the commit. So this has definitely helped us. So flashing lights, we don't have this in all the offices, but these are kind of the status lights for your Jenkins job. So you can hook this into like a USB port, and there is an API that you can use where if your job has been failing for the last 10 builds, it will flash orange. So anybody who passes by your cube is gonna see, hey, did you have a, what the hell did you do? So it helps get that visibility and more accountability. But after a point, if I am the one who always has a red light, I'll just unplug it. But this has definitely helped for a lot of teams. Here, it's a small office, so it doesn't help much. But in our bigger office, we have these flashing lights, and other teams who walk by and see those red, people get asked about those things. I mean, it's hard to define a timeline. I think we try our best to resolve it as soon as possible, but a lot of times if we have a lot happening and a lot of things on our plate, it might get delayed. But from a best practice perspective, we should never have a red light. The worst we can go, or we should go, is orange.
Maybe only urgent issue.
Well, maybe yeah. We can have some kind of intelligence built in where if this type of test failed, then do a red, otherwise do an orange kind of thing. I don't know, but we'll have to figure something out. The last one we have not implemented, and I don't think anybody wants your manager calling and being angry at you. What the fuck did you do? Why did you not fix it? Sorry. But this is something that I would say most people don't do it. So this concept, I think we talked about how can we make our test much more reliable and robust. But in reality, you cannot have 100% reliability or 100% solid UI tests. So Facebook uses this concept of I don't know what they call it, robo-sheriff or something, where you automate the automated tests. So what you really do from a concept perspective, You get the reliability. So for us, we get the reliability through the API. So we make a query to Elasticsearch saying, give me the reliability of this test. And the reliability is basically how many times the test has passed and how many times it has failed in last 6 hours, 8 hours, whatever you want to call it. And you calculate that and then define whether the test should be moved to regression or whether the test should be moved to TUT. So it works both ways for moving tests that have become reliable into regression and the tests that have become unreliable to move into TUT as well. That helps with keeping our flashing lights green for the most part. And it also helps us sometimes to miss some bugs, because if the test gets moved into TUT, a lot of times people overlook it as a badly written test and not really verify the actual thing. But that's kind of more of a process thing than a real problem with the actual system. So this is where we really want to go. So we have been able to implement the aspect of actually getting the reliability, but we still have to overcome the challenge of being able to move tests around without breaking anything existing. Some of the other things that we want this test management tool to be able to do is selectively run certain tests. So as a developer, I know I made a change in this part of the application, so I want to be able to regress that particular aspect, and I know here are all the tests that I can run. So we want to be able to build those capabilities into this test management tool so that when I commit a code, I don't have to run every single test that we have automated. We also want to be able to have some kind of configurable rerun aspect, because I think a lot of people you must have encountered that stupid bug which happens intermittently and it doesn't happen always. So being able to rerun those tests multiple times from a developer perspective is going to be useful, because then they can run it multiple times and see where and when it actually fails and how many times it fails. And that would give them more quantifiable data to say whether this is a critical or a major bug or not. Because if you do it through an automated process, you get the results much more quickly and faster way. Being able to create Jira tasks for a failing test is another thing that we want to achieve, so that we use Scrum for as a practice or as a process. And we want to be able to give that information and get it in front of the entire team, so that when a test fails, we have something to say, hey, this is what I'm going to actually work on, and it's not an up in the air or an abstract thing that people do on the side. Because if it takes more time, then we want to be able to measure those and use that on the actual dashboard. So next I want to kind of demo the actual dashboard on how it looks like right now, and show you some code of how we have actually done it. So this is our current dashboard for last week. So as you can see, most of our jobs are green, like 99% times the smoke worked. There were 5 failures in the second job, but looking at the relativity, it's like 99.5%. So it says it's 100% from a graphical representation perspective. We also look at, so the thing that I was talking about, the 4 categories of, fast, reliable, slow, unreliable. This row helps us define those tests as well. So as you can see, this guy is an unreliable test, and it takes freaking 945 seconds to run. So we want to be able to either get rid of this test or refactor it into smaller pieces. Because since we rerun the failing test, this 945 is twice the time it takes to actually execute this test in the job, it gets executed. So we definitely, so even though it is a passing test, it's a long running test, and it's way too long for us to be having these kind of things. Execution times, and then exceptions and method execution as well. So once, let's say, you want to see for this build, let's say as an example, so we ran 179 tests, and in nightly there were 6 failures. And let's say you want to see one of the tests that failed. So you just click on it, it shows you all the failing tests and why they failed. You see all the exceptions here. You click on this JSON blob, and then it gives you the link to the actual Jenkins job. You go there and you look at the failed test, and you go inside the actual failing test.